All right, this is the video lecture for Unit 3.6 in quadratic function. So we're going to learn about the quadratic formula. All right, and hopefully here you can notice that I did have a new addition to this video recording. I have a digital version of a calculator, so this way I can show you how to plug things into your calculator a little bit easier, and hopefully ease some of the difficulty that you might be having with converting from what you see on paper or what you see on Apex to actually plugging this stuff in your calculator. And then again, it'll also help you see exactly what I'm talking about when I'm typing in values in my calculator here. So please bear with me. I'm a little bit new to this digital calculator. So give me a minute here while we kind of work through it together. And then also, I do want to point out that this is a different version of a calculator. So I apologize that I don't have, the TI 83s or 84 version. I only have the TI Nspire. All right, so again, my calculator is going to look a little bit different here, but the buttons are still going to be the same. They might be in different places. You might have to look a little bit harder for them, but the buttons are still going to be the same here, right? So you're still going to have a plus sign. You're still going to have a caret sign, and I'll talk you through that as we go. All right. So starting off here, 3.6, again, quadratic formula. So looking at the overview here. So this is really, really going to be important for us because some quadratic equations aren't very obvious as to what the answers might be, right? We worked a lot with some simple quadratics. We worked a lot with things that maybe we could either have perfect square trinomials or we could complete the squares, right? But sometimes we just don't have that ability and it's not very obvious. So this is where this thing called the quadratic formula is going to come into play, all right? And again, a lot of this is going to deal with utilizing the quadratic formula. Again, I'm never going to have you memorize something, so I'll always have that available to you as we go through this, okay? But it's all about understanding how to apply, picking up patterns, and then again, being actually able to just execute the process, all right? So let's, apologies. Before we get started here again, there are two quizzes. Okay, there are two quizzes. So one is on complex numbers and discriminants. Okay, so again, I'll point out the section for that. And then the next quiz is actually on the quadratic formula. So taking those complex numbers and discriminants one step further and actually solving for the entire quadratic formula. All right, so now let's get going. Okay, so the quadratic formula. Okay, before we get into actually learning that, okay, again, re-highlighting here that we learned how to factor, and one of the easiest ways we learned how to factor was to complete the square and make these perfect square trinomials. So to just remind you of what those steps looked like, okay, we started with an expression that was x squared plus bx, right? And it might have equaled something on the other side of the equation, right? But if we were just looking at that specific expression, it looked x squared plus bx, right? Then we were able to add b divided by 2 and then square that, right? We would add that to the expression, and that would complete the square there. So that way, if we factored it, our factor would look like this: x plus b over 2 multiplied by x plus b over 2. When we simplified that, that's x plus b over 2, and then that quantity is squared, right? So that's how we were able to solve if we were able to complete the square. But again, like we talked about, you might not be always able to do that. So we have this thing called the quadratic formula, right? And obviously, quadratic formula is used to solve quadratic equations, and we'll talk more about that in the next slide or two, okay? But again, the important thing here is quadratic formula is x equals negative b plus or minus the square root of the quantity b squared minus 4ac all over this 2a quantity. All right, and I'll show you how we get that and how to memorize that and how to do that. But again, if you don't remember it, not a big deal. But I was always taught a song when I was in high school of how to remember this one, and it's kind of lame, but that's just kind of who I am and what I like. It makes sense to me. So we'll go through that a little bit more later here. But these variables, b, a, c, all come from our original quadratic formula in this standard form. Okay, so that's going to be one of the key things. That's why we focused so heavily in the last couple of lessons on getting the quadratic equations into this standard form. Okay, getting the quadratic equations into this standard form. All right, so we'll spend 30 seconds on this. It's not a big deal, but if you want to figure out where the derivation or how we came up with the quadratic formula, all right, if we start with the standard quadratic equation, okay, we're able to divide everything by a so that the coefficient of the first term, that x squared, becomes 1, right? So if we divide everything by a, there we go. We've got everything divided by a. Now, if we subtract c over a from both sides, right, it moves that c over a term to the other side. All right, then if we take half of the x term and we square it, then we add that to both sides. So it looks like this, right? Looks like this. All right, then we factor the left-hand side. All right, if we're able to factor the left-hand side, we get that factored of the perfect square trinomial that we've been working with, right? Then if we take and simplify the right-hand side of the equation, right, we get that b squared minus 4ac over 4a squared. And then we take the root of each side. And when we do that, we're left with a square root on top, but 4a squared is reduced to 2a. All right, and then finally, the last step there is we move over that positive b over 2a. We move it over to the right-hand side of the equation, which makes that now negative b over 2a. We combine like terms, right, and then we can solve for x there. All right, no, you will never ever be asked in this class how to look at this and where that comes from, but just in case you wanted to see it. All right, but again, it ends up with this equation: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. In 5 words or fewer, name a special process used to find the quadratic equation. Right? Well, that one was completing the squares. Right? We had to complete the square in this step right here. We had to complete the square so that we could then factor, right? And we were able to factor and get this perfect square trinomial, right? So that was one of the special processes used. Okay? If you and again, you don't have to derive the quadratic formula each time you use it, all right? But you do have to be able to apply this quadratic formula when you're looking at different equations. So again, the key is going to be able to figure out what those different variables stand for. So a is the leading coefficient, b is that x term, that middle guy, and then c is the constant, right? So if we're looking at, let me go back here, if we're looking at our quadratic formula in standard form, right? A is the first coefficient, B is that second coefficient, and C is our constant. All right? And our quadratic formula is this x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right? And the song that I learned in high school, which is why I'm saying it a certain way every time, very lame, don't judge my singing here, but it literally was x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Right? So that's just something that we learned to help us get that equation memorized. But if you don't want to memorize it, not a big deal. Write it down, have it on a piece of paper next to you, or have it on that study sheet next to you. All right? But you got to know how to apply this, right? So when we're looking at these two equations here, you got to notice that the a term, okay, the a term for this first one is going to be negative 3, right? Because it's that x squared. Then you've got this b term here is 5, and then your c term is 6. So it would be negative 3, 5, and 6, right? And the reason we know that is because this equation is in standard form. You've got your a squared, ax squared, plus your bx, plus your c, all equal to 0, right? So again, getting it in standard form is going to be the key here. All right, for this last one here, okay, our a term is going to be 2, our b term is going to be 7, and our c term is going to be 4. And if you don't believe me, there you go. We can check the answers. All right, and then in the box below, express what number a cannot be. A cannot be 0. A cannot be 0. And it says the denominator of the quadratic equation, which means that number down here. And the reason that A cannot be 0 is because you cannot divide by 0. It will usually give you an error if you try that in your calculator. So 5 divided by 0, just to get a little familiar with this, equals. Won't even let me do it. Won't even let me do it. Okay? Undefined. Okay, it is undefined, right? Or yours might say error, means it's not possible, right? So that's the reason why A cannot be 0 in this example. All right, plus if A is 0, then it no longer is a quadratic equation. It's an equation for a linear line, right? And therefore we cannot solve it using the quadratic formula. All right. Now, I think this is kind of the simplest part here. Okay, once we've got it in standard form, we identify what the variables for A, B, and C are. You just plug them into the equation and then you simplify, right? And the simplification might be a little bit difficult, but if you follow and write down your processes, you can get this and work this all out here, right? So the solution for the equation ax squared plus bx plus c is equal to, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So you're going to plug in all those values. And then what I need you to notice here is we've got this plus or minus. We've got this plus or minus there. So what that means is you would do this entire thing. You'd go negative b plus square root of b squared minus 4ac over 2a. Then you would do this again, which is negative b minus the square root of b squared minus 4ac over 2a, right? So you have a positive version and a negative version of this equation. All right, so if we look at example 1 here, we apply the formula, right? So we just plugged in. We've got our b value is 5, our c value is 6, and our a value is negative 3. So we just plug that in, and then we simplify, right? We plug that in and we simplify. All right, and if you can't get it any simpler than the square root of 97, you leave it at the square root of 97. And by that, I mean if you were to go to your calculator and you were to type in square root of 97, okay, so for me, I have to click Control and then my X squared button because you can see there's my root. There's my root. So if I go, though, and I type in square root of 97, if that is not a whole number, you do not simplify, okay? An example where you would simplify is, all right, square root of 16. Oh, that's 4. So I could simplify square root of 16 down to 4. But for this one, I stop at square root of 97 since it doesn't give me a whole number. All right. Example 2 here, again, A is 2, B is 7, C is 4. I apply the formula. There we go. Okay, I simplify. All right, I do my square, I do my multiplication, I end up with my subtraction, right? And I'm left with square root of 17. So I've got negative 7 plus and minus the square root of 17 over 4. All right, and if you want to check to see if we can go any further, square root of 17 is equal to 4.1, so we leave it as the square root of 17. All right, so moving forward here, not every type of equation can get solved by the quadratic formula, all right? So these are kind of your golden rules for using the quadratic formula, all right? There can be no term whose degree is higher than 2, so you cannot have an x cubed. You cannot have an x to the 5th, right? That would make it not a quadratic equation. Okay, the coefficient on the x squared term cannot be 0, so a cannot be 0, right? Again, if a is 0, that's no longer a quadratic equation. All right, and then the right-hand side of the equation must be 0, which means we've got to have our equation in our standard form. We've got to have our equation in standard form. All right, so tip 1, okay, again, x squared is the highest term. All right, tip 2, coefficient on the x squared term can't be 0. It can be 2, it can be negative 5, it can be negative 1,000, it just can't be 0. Right, and then finally, that last tip there, okay, the right-hand side of the equation has to be equal to 0, right? Again, these all are in our standard form for quadratic equations. All right, moving forward here, when the right-hand side isn't 0, okay, when the right-hand side isn't 0, this is pretty simple here, okay? If it's not 0, all you got to do is put it in the standard form, right? We worked a ton on that in the last couple of units here. So, for example, if the right-hand side has a 2 value there, you just subtract 2 from both sides, right? You subtract 2, get it in that standard form, you're good to go. We apply the formula, right? And then if we were to continue this, we could simplify from there. Okay, for number 2 here, you've got a 2x. Great, just move 2x to the other side by subtracting 2x from both sides. All right, we then apply our formula and we would simplify from there. Last one here, 7x plus 1. Great, you subtract 7x and subtract 1 from both sides. There you go, you're left with x squared plus x plus 5 equals 0. We're in that standard form. Okay, we're in that standard form. So then when we apply the formula, we look like that, right? And again, we would simplify down and solve further, but this is just showing you, again, you got to get it in that standard form of our quadratic equation. All right, so sometimes when you use the quadratic formula, you can end up with a negative number underneath the radical sign. And again, the radical sign is this square root, right? So if I click on radical, right, it is that square root symbol. Okay, it indicates the square root. So if you have a negative under there, right, if you have a negative, it is what this thing we call as an imaginary number. Okay, it is this thing called imaginary number. Right, and an imaginary number is referred to with the letter I. So, for example, here, if I have square root of 9, okay, square root of 9, we know that's 3, right? 3 times by 3 can give me 9. But if I have negative 9, and I'm trying to take the square root of negative 9, nothing multiplied together is going to give me a negative 9. So when I take the square root of a negative number, right, I act as if that negative's not there, right? So square root of 9 is 3. And then since it's negative, I add this little I, which stands for imaginary, right? So it gives me that imaginary number. All right. Now, imaginary numbers are part of a larger set of numbers called complex numbers. All right. And complex numbers are in this form a plus bi. A plus bi, where a is a real number and bi is an imaginary number. So, for example, here, okay, 3 plus 4i. That would be a complex number. Or if we kept this 3i from above, we could say 1 plus 3i, right? 1 plus 3i. Or 1 minus 3i. Okay, that's still an imaginary number. All right. Now, complex numbers are difficult to understand, but they are useful in a lot of different things. But we're not going to really focus on using them a whole lot, right? We're just going to know how to change a number into these complex and into these imaginary numbers, right? We're not going to get into the practical application of imaginary numbers at this point. All right. So again, key here is you got to know that if we're taking the square root of a negative number, right, that makes it an imaginary number. And if we can simplify that down, we call this, square root of negative 9 is not just 3. It's now 3i, I standing for imaginary. All right. And if we have two things added together, so a number plus that imaginary number, right, we now have this complex number. So example, 3 plus 4i gives me that complex number. All right. So if we get back to the quadratic equation, and it all makes sense here, I promise. Okay, if we get back to the quadratic equation, the quadratic formula, that's that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. Now, when we do this, we can actually break this up into smaller parts to give us more information without having to do the full process every single time. All right. So this part that's underneath the radical, okay, so underneath that square root symbol, that b squared minus 4ac, has this special name called the discriminant. Okay, it has this special thing called the discriminant. All right, and basically, the sign of the discriminant can tell us how many solutions we're going to have to this problem, right? So we can either have one real solution, we can have two real solutions, or we can have two what we call complex solutions, right? So those complex solutions would include the complex numbers, right? So again, to remind you, it would include the complex numbers, which is going to be a real number plus an imaginary number. All right. So if we're looking at the example of a positive discriminant, so b squared minus 4ac results in a positive number under that square root, right? So for example here's the equation. If we do the discriminant, it's 17. it's going to give us two real solutions, right? And that solution may or may not have this square root symbol in the end. If we can reduce this down further, we will, but you're going to end up with two real solutions, all right? On the flip side here, if we have a negative discriminant, right? So the underneath there is negative, right? It follows the same process, but now we have a negative square root. We have a negative square root, and as we just said, if we have a negative square root, that now makes it an imaginary number. So we would have these two complex solutions. All right, and then finally here, if that b squared minus 4ac is 0, okay, if that's 0, that ends up canceling out a lot of things here. So there ends up only being one real solution. All right, so what that looks like here in words, okay, if the discriminant is positive, that b squared minus 4ac is positive, it's going to have two real solutions. If it is 0, it has one real solution. And if it is negative, right, negative square roots give us these imaginary numbers, which result in two complex solutions there. All right, so if we're confirming what we know here, or what we just learned, the quadratic formula can be derived by factoring. Right? This is going back here. The quadratic formula can be derived by completing the square. Okay? So again, this is going back to what we just learned. Okay? So the quadratic formula can be derived by completing the square. All right? We have to complete the square first, then we can factor it. Okay? We had to complete the square first, then we could factor it. All right? The quadratic formula is the negative b plus or minus the square root of b squared minus 4ac all over 2a. All right? Again, imaginary numbers are where you take the square root of a negative value, and that's going to give you a value with the letter I, right? I standing for imaginary. And then this thing called a complex number, we would have some number plus an imaginary number. So we'd have a real number plus an imaginary number, so an a plus bi, and that's going to give you a complex number. All right? And then lastly here, the discriminant. That's what's under that square root symbol. That's that b squared minus 4ac, and if it's positive, you get two real solutions. If it's a 0, you get one real solution, and if it's negative, you have no real solution, meaning you have two complex solutions. Okay? So to use the quadratic formula, there can be no term in the equation whose degree is higher than 2, right? 2. Okay, that's talking about x squared. It can only be x squared. It can't be x cubed or x to the 5th, right? No, nothing higher than x squared. If the right-hand side of the equation is not 0, it is definitely possible to still use the quadratic formula, right? You just have to change it into that standard form. Now, if the discriminant is 0, right, that b squared minus 4ac, that thing under the square root, the equation has one real solution. And again, if the discriminant is positive, then it has two real solutions. All right, and again, that's having that study sheet next to you. That's going to be really, really helpful with this. All right, so again, these are some sample quiz questions. Okay, this is going to be like what you see on quiz number 1 here. It's going to be super, super important for you to go through and try these problems. You're going to get instant feedback on what you know. Okay, on what you know. All right, so again, this is all about, can you apply the formula? Can you get it in the standard form? Can you apply the quadratic formula and simplify here? All right. Now, moving forward here, now we're actually going to solve the polynomials. We're going to solve using the quadratic formula, okay? So, and the quadratic equation. Okay, so now we have, when we are solving the quadratic equation with our new formula here, okay, we can find the roots of the quadratic, all right? And the roots are the zeros, right? Okay, values for which the function equals 0, all right? We talked about it being roots, we talked about it being solutions, zeros, all of the same thing, all right? But it's where the graph crosses the x-axis, right? So in our graph here, it's where it crosses the x-axis, all right? Or our x-intercepts. Now, if a polynomial's roots, again, it's where it crosses the x-axis, known as the x-intercept, okay? And you can see on this graph here, right, it's got two x-intercepts, or two roots of this, right? And so if we just look at the graph here, if we said, okay, this is the equation, and this is what the graph is going to look like. Looking at this, okay, I've got a root at -2, 0, and I got a root at 4, 0, okay? So what we end up doing is if we were to just solve this, right, or factor this down, okay, if we factor this down, the x values you have here, you take the opposite form of it, right? So right here, this root is 4, 0. So one of my factors is x minus 4. One of my factors is x minus 4, because this is positive 4. You've got to have it be plus 4. Sorry, you've got to turn the plus 4 into a minus 4. All right, same thing here. I've got a root at -2, 0. So this is x is equal to -2. Therefore, my factor here is x plus 2. All right, again, it's working backwards from what we just learned in the last couple of units here. All right, so again, you can find the roots by setting y is equal to 0. You can graph it, you can solve it, right? So if you can do that, then you can find the roots of all these answers here. All right, so again, we worked a lot with looking at the equation. We worked a little bit on plotting these, right, in the last couple of sections here. And now we're going to look at again, how do we solve this further? How do we actually figure out what the values of x are going to be? What are those x-intercepts? So if you got an equation that looks like this, okay, you switch sides, you want it in that standard form, ax squared plus bx plus c, right? Now we apply our formula, okay, so my a value is 1, my b value is -1, and my c value is -1. But I apply my quadratic formula, okay, so -b plus or minus square root of b squared minus 4ac all over 2a, right? I apply it. I simplify, okay, I simplify. Now, what I would do is I will have two answers to that. So let me back up here. Okay. When I simplify here, I have a positive version. So I would have I'd have 1 plus the square root of 5 over 2, and I'm going to have 1 minus the square root of 5 over 2. Okay. So when I look, I got 1 minus the square root of 5 over 2 and 1 plus the square root of 5 over 2. Right? And those are my roots. Those are my answers. Those are my solutions. Right? And they end up being my x-intercepts because we had y set to 0. All right? We had y set to 0. Because again, if we looked at this, it was 0 equals x squared minus x minus 1. Right? So when we set y to 0, we got this first answer and the second answer. All right? And then again, it's 2. We had 2 real solutions. All right, I know the square root can make people feel uncomfortable, but it is a positive square root. So we have 2 real solutions. Okay? And here's a couple more examples of when the discriminant is positive. That thing under the square root is positive. All right, so I'll zoom in here. This is one that I really, really like here, okay? Because when we solve this down, and they kind of skipped a couple steps here, but we end up having 2 squared, and I can show you in my calculator what that looks like. So 2 to the power of 2, right? We have 2 squared minus 4 times by 1 times by -3. Okay, that's 16. Okay, that gives me 16. Oops, sorry, didn't mean to do that one. Okay, so if I do the square root of 16, that gives me 4, right? So what this really looked like was -2 plus 4, right, divided by 2. That's how I got my first answer here. Okay, I did -2 plus my discriminant divided by 2. All right, and then I have to do the other version of that. So I would have to do -2. Sorry, I have to do -2 minus 4 divided by 2. And I get my x equals -3 here, okay? And we'll walk through a couple examples where I handwrite these out for you so you can see all the steps. But, right, this is showing you the discriminants, and it's showing you if the discriminant is positive, right, you can reduce it down further. All right, it doesn't always have to end up with something that looks so complex with this square root of something. Okay, it can get simpler. All right. Okay, so for example here, this is showing you if the discriminant is a negative number. All right, so if the discriminant is a negative number, moving forward, I've got A is 1, B is 2, C is 6, right? Because I set that equal to 0. All right, now my discriminant there ends up being, when I solve it down, it ends up being -20. So its discriminant is -20, so there's no real roots. And what that would look like graphically is if I graphed this equation, it's going to look like this. Right? And since I have no real roots, what that means is it doesn't cross the x-axis. It doesn't cross the x-axis at all, right? Doesn't cross the x-axis. It could either be opening upwards here, or it could be somewhere down here and opening downwards, but it's not going to cross the x-axis, all right? Now, if the discriminant is 0, right, if that discriminant underneath the square root sign is 0, okay, it's going to look something like this. Right, so here's an example. Discriminant ends up equaling 0. Okay, and that means I'm going to have one real solution. I'm going to have one real solution. And what this is it's a perfect square, right? It is a perfect square, okay? And the reason that is because it's going to touch down, has one perfect answer, one perfect root that is on my x-axis. And then it's going to continue back upwards. Okay, or again, it could be opening downwards. It could touch once, come back down. But if it is, the discriminant is 0, it has one perfect root answer. Okay, so a graph tells you where the roots of an equation are, right? The roots, the x-intercepts, the solutions, any of those words here. Okay, what is the root of the polynomial? It's where it crosses the x-axis. It's when, again, you set the polynomial equal to 0, right? And we solved both of those factors when we set it equal to 0, right? So those are my roots there, okay? And then, how can you use the discriminant to determine how many roots? Okay, this is super, super important here. Positive has 2, 0 has 1, negative has none, all right? This is kind of your summary chart there. All right, so we'll go through a couple of these, and again, I'll be using my calculator here to show you, but I'm looking for, it says how many roots does it have? So we're going to be using the discriminant only for this question here. So for the discriminant, I've got b squared minus 4ac. All right, so if I come over to my calculator, I'm looking at 2 squared, okay, minus 4 times by 1 times by 9. I end up with -32. I end up with -32. So I'm going to have 2 complex roots. I'm going to have 2 complex roots because it's going to be a negative number. All right. For this next one here, I'm going to do -12 to the power of 2 minus 4 times by 9 times by 4. Right, now, I think I messed something up here symbol-wise, so give me a second. And this is why parentheses is super, super important. There we go. Okay, so again, parentheses can be really, really important here. Okay, so I found out on my calculator it doesn't like negative symbols. So if you're going to take the square of a negative, I suggest that you put that negative in parentheses. Okay, so when I do that here, I now get a 0. So since I have 0, it's going to have one real root. It's going to have one real root. Okay, and then we'll do one more here. I've got 8 squared minus 4 times by A, which is 3, times by 2, which is C. Nope, again, apologies. I am new to this digital calculator here. Minus 4 times by 3 times by 2. There we go. Got number 40. Okay. So since it's positive, I'm going to have 2 real roots. Okay. And again, be really, really careful with how you plug this into your calculators, or take it step by step at a time. All right. So again, I'll leave this to you guys to practice. All right, you do have the ability to do this, but again, it's going to come down to plugging in your A, B, and C values into your quadratic formula and then simplifying from there. Okay, so finding the roots of your polynomials, right? Again, this is going to be really, really important. All right, and I'll leave this for you to check because, again, these are very similar to your quiz questions. So if you can do these, that means you understand the material and you should feel confident moving forward. All right. And then finally here, this is the last thing I'll wrap it up with is the soccer problem. Okay, so trying to figure out who kicked the soccer ball further. All right. Now, Carlos's kick looked like this, and Carly's kick looked like this, right? And it had 2 different equations, all right? And if the graph looked like that, right, it's asking what does the x-axis represent, since the parabola represents the path of a soccer ball. The x-axis is the ground, right? So we got to keep it in real perspective here. The x-axis would equal our ground, all right? So if we were to look at these graphs here, we could find our real solutions, right? So we find our solutions. So Carlos's kick has 2 solutions, x equals 10 and x equals 25. Carly's kick is x equals 10 and x equals 30, right? They both have x equals 10 because they dribbled 10 yards or 10 feet and then kicked the ball. But regardless, you can see here clearly Carly's kick crosses the x-axis at a farther point of 30. So the answer for who kicked it farther would be Carly, right? Carly would kick it farther. Okay. Okay, so we're going to stop here for part 1 of the video. And I know this one ran a little bit longer, so I'm going to try to take you through quickly the study guide and through the checkup here. So let's get rolling with the next part of this. I want to remind you that the answers to the study guide are posted already on Google Classroom, so please feel free to take a look at that, and obviously you can always get them on Apex. But, okay, if we go through this quickly here, all right, reminding, look back at the page numbers if you need it, okay? If you get something wrong or if you don't understand, go back to the page numbers where this can be found, all right? But one of the main ideas here is the quadratic formula can be used to solve any quadratic equation, even those perfect square ones, right? But mostly we're going to use this for the complex ones that we can't innately figure out or figure out very easily, right? And then one of the rules here is that A cannot equal 0. If A equals 0, it's no longer a quadratic equation and it doesn't work out for us, all right? Quadratic formula here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, the faster you can pick that up, the easier it's going to be for you. All right, now, couple rules here. No term in the quadratic equation can have a degree higher than 2, right? X squared is the highest. The coefficient of the x squared term cannot be 0, and the right-hand side of the equation must equal 0. All right, it's got to be in that standard form where that right-hand side equals 0. All right, so if we look at actually figuring out how to solve this, right, we look and see, okay, first off, our equation is in standard form. The right-hand side of the equation is 0, so we're good to go on that one. Then here, next, we're going to identify our variables, A, B, and C. We identify them. We plug them into our quadratic formula, right? We just straight up plug them in for where they go, all right? We then simplify, and again, I made a couple mistakes on my calculator too, so please be careful with how you plug this into your calculator and how you choose to simplify, all right? And then once you simplify here, you're going to write your solution. So as I told you, you're going to have a positive solution. So you're going to go through and do the plus version, and you're going to go through and do the negative version. All right. And again, if you can simplify the square root down further, great, you're going to do that. But since we typed in our calculator square root of 97 and it didn't give us a whole number, right? It gave us something insane like 9.845 whatever, okay? Since we can't simplify it down to a whole number, you're just going to leave it as square root of 97. All right, and then that's a positive value here, okay? So since that's a positive value, again, we're going to have those two real solutions. All right. Now, looking at this discriminant, right? So the thing under the square root, it is the expression that is under the radical sign or the square root sign of the quadratic formula. It tells you how many solutions a quadratic equation will have. It's going to tell you how many roots the equation has, right? So how many times the graph, the equation touches the graph, right? The x, or crosses the x-axis, right? How many x-intercepts am I going to have? All right, and the discriminant, again, is always that b squared minus 4ac. All right, and there was three cases here. Positive would have two real solutions. Zero is going to have one real solution. Negative is going to have zero real solutions because it has those two imaginary or complex solutions, right? Involving that letter I. Okay, I standing for imaginary, right? And that comes into play when we have the square root of a negative value. All right. So then finally here, looking at this last one, the discriminant is positive, and we know that because it has two real roots. For this one, it has one real root, so we know that the discriminant is 0. And this one never crosses the x-axis, so it has no real roots, making the discriminant negative there. All right. So again, that's the study sheet. That's going to be super helpful when you're going through this. All right. Again, you got two quizzes here, one on complex numbers and discriminants and one on actually solving the quadratic formula. All right. So now we're going to look at our checkup here for 3.6. All right. And again, reminding you, all the answers to this are posted already for you on Classroom, but let's walk through a couple key examples here together. All right, so moving forward with these practice problems here. All right, I want to point out here the quadratic formula is already written for you, so please feel free, again, always have that with you, use that. All right, for all of these little sections here, we're just going to do one of the problems because they all are pretty similar here, and I know these can get complicated or just lengthy in general. So we're going to do one of each of these. So for these first four, it says find solutions for the quadratic equation. All right, so we're actually looking, when it says solutions, we're looking for x equals values, right? And we can have up to two values here. All right. Now, first thing, you got to make sure before you get started is that it follows all the rules. And by rules, I mean, look, it's got x squared is the highest polynomial term. Great. The right-hand side of the equation is equal to 0. Awesome, right? We have no other weird terms there. And then a is obviously greater than 0. Okay, same thing here. We've got 2, so it's greater than 0. We've got x squared, awesome, and then the right-hand side of the equation is equal to 0. All right, so for this example, we'll do problem number 2 here. Okay, we'll do problem number 2. So first off, after we've identified that this equation is in the right form and it's good to use, okay, we're going to identify our different parts of our equation. So we're going to identify what A, B, and C are. So A is 2, B is 3, and C is -1. And if I look here, all I have to do now is plug into my formula. So x equals -3 plus or minus the square root of 3 squared minus 4 times 2 times -1 all over 2 times 2. All right. So now if I start to simplify this problem down here, okay, I'll try to simplify this down a little bit. X equals -3 plus or minus the square root of, I've got 9 plus 8 all over 4. All right, so x equals -3 plus or minus the square root of 17 over 4. Right, and this is where I have two totally separate problems because of this one part right here, that plus or minus. So one of my answers is -3 plus the square root of 17 over 4. And the other answer is -3 minus the square root of 17 all over 4. So those are my two solutions to this quadratic equation here. All right. And again, hopefully that seems pretty simple. It's just following the process and what I like to call plug and chug, right? You plug it into the equation and you chug through the different calculations. All right, for 5 and 6, find the discriminant. So again, to remind you, the discriminant, we are talking about b squared minus 4ac, right? B squared minus 4ac. So when we look here, we have nothing on the other side of the equation, right? So that's effectively like saying x equals 0. And we'll look at, let's go with number 5 here for this one. So again, if I identify my different parts, A equals 1, B equals 5, and C equals negative 4. So my discriminant is b squared minus 4ac, or 5 squared minus 4 times 1 times negative 4. So I've got 25 plus 16. 25 plus 16, and that turns into 41. All right, that turns into 41. So my discriminant for this first equation is 41, right? And then again, based on the discriminant, we can figure out, am I going to have 2 real solutions, 1 real solution, or 0 real, because I'm going to have 2 imaginary, right? So that would be why this can be important here. All right, and then for 7 through 10, find the roots of the polynomial. Okay, find the roots of the polynomial. All right, so again, finding the roots is like saying finding the solution. Okay, finding the solution. All right, so we're going to follow the same process we've done for all of this. So let's go with, sure, we'll do number 9 here. All right, we got to figure out what A, what B, and what C are. So A is 3, B is negative 2, C is 7. All right, and then I'm using my quadratic equation, x equals negative b plus minus square root b squared minus 4ac all over 2a. So now I plug into my equation, negative 2 plus minus, square root of negative 2 squared minus 4 times by 3 times by 7 all over 2 times by 3. All right, and again, I'm very careful to make sure that that negative 2 is in parentheses, and then that quantity is squared. Got to make sure that mistake doesn't happen in our calculators. All right, so now if we start simplifying down, negative 2, that makes that positive 2, plus or minus. All right, negative 2 squared gives us 4 minus 4 times 3 times 7 gives us 84. Okay, that gives us 84. All right, and then that is over 2 times 3, which is 6. All right, so simplify down one more step. 2 plus or minus square root of negative 80 over 6. All right, so right now my discriminant is negative. So this means I'm going to have 2 imaginary solutions. Okay, 2 imaginary solutions. All right, so my final answers are going to be x equals 2 plus the square root of negative 80 over 6, and x equals 2 minus the minus negative square root of 80 over 6. So those are my 2 solutions. All right. The only thing I want to point out that they didn't have as an example here that I wish they would have is, let's say we get to x equals 5 plus or minus the square root of negative 16 over 2. All right, negative 16 over 2. All right. Now, we can simplify this negative 16, the square root of negative 16. We can actually simplify that down, right? Because square root of 16 is equal to 4. But since we have a negative 16, right, this is where that imaginary number I comes in. So that is actually 4i. So what we can do is say x is equal to 5 plus or minus 4i over 2, right? Which then results in our two equations being 4i over 2, or x equals 5 minus 4i over 2. Okay, so that is an option if you can simplify down. All right, but either would be 1,000% acceptable. You can also leave it as negative square root of answers. Okay, so again, I left you a couple problems here to try on your own, and the answer keys are again posted on Google Classroom. So take a look at those.